Hello, welcome to stream number 26 of this series where we're programming an NES game from scratch in assembly language. I feel like we've had a lot of gaps here in the series lately, with me being on vacation and then not streaming last week, but also just a lot of sort of things that we're diving into that are a little more complicated in terms of, or at least the way we're doing them right now, maybe a little more complicated than stuff we've done before, because we're trying to load the map dynamically. So before I started recording, I launched the game, and so you can see we have the background, and we actually have a status bar that is here on the on the bottom that you can see when you pause the game, or sorry, set the update on the scan line over here at 200. That's where we're shifting over to the right, to the right part of the name table, after we switch to mirroring vertically instead of horizontally. So that's where we're at. I want to get the level data loading in based on what we have here, and then I don't want this stream to be too long because I have to get up early tomorrow and catch a flight. So I want to get this loading in so that we can stream these metatiles in, and then based on, once we get that going, it should stop once we hit the count of the number of rows, which is that first byte in the level data. And then once we have that going, I want to try and start populating data here in, or here really, in the status bar of the game. And I believe we had, in a previous stream, I had put some junk characters into here just to make sure that that was actually working properly. And so we had, yeah, so it was at scan line 200. So we had populated this with tile 1, I believe, and it properly filled up the bottom of the screen with some junk characters. So these junk tiles here are not correct. These are because, if you remember last time, we were trying to figure out what math we needed to do in order to load this next row of data into the name table. And I had logically I had wanted to do that based on the position of the camera in the level. But it occurred to me after we did this that I was actually doing this in a more complicated way than necessary. So, I mean, what was good is that we got to deal with the 16-bit math for the 16-bit divide by shift and multiply by shift. And if you remember, what it was doing was we had two 8-byte values, and we were rotating right where we had the carry here. This is your carry flag, and if this bit was 1, when you did the rotate right, it shifted that bit onto the carry, and if this was 0, it got shifted over and this became 0. And then what we needed to do is we needed to rotate right on this byte, and just as with this one, this bit got rotated off into the carry, but we didn't care about that. We didn't care about that so much as we actually cared about the fact that the carry gets added to the most significant bit of the byte when we do the rotate right. So it allowed us to carry over the bit from the other byte to do the 16-bit shift that we wanted to do. So we worked that out through a series of these clear carry, rotates, and stores that we were doing, and then we had to, in addition to dividing, we had to rotate left to multiply, and it was the same process just in reverse, essentially, using that carry to carry the bits over from the least significant byte to the most significant byte of the 16-bit value. And that all worked, and we eventually, after plowing through it, got the value we were looking for, which was that when we did that lookup of the camera location, and if you remember, I was incorrectly using the value 8 instead of 32 for the divide initially. I finally got this value of 8, and all seemed well. But it occurred to me that we didn't have to really be doing that. Yes, you can do it that way, but because we're not doing arbitrary moves along the y-axis of the map, where it could literally be anywhere on this map data, and we're always just increasing, really all we need to track is the fact that the value has increased until the point that we reach another threshold for another row that needs to be populated in the name table. And at that point, we just keep counting the rows within this metatile row. And then once we've surpassed 8 rows within there, we increase to the next metatile row. So to explain that a little bit further, it's actually a much simpler process than what we were doing before. So if I clear this canvas, basically what we're saying is once we load the first screen, which is what this is here, we need to say, okay, we have this 8 by, what is this? This is 7. We have this 8 by 7 grid, right? So we want to do the 8 by 7 into this metatile, which should be 56, right? So our starting point is 56. And then we have 2 counters. Wait, do we have 2 counters or do we have just one? Let me think about that. No, we just have 1 counter. So we have 1 counter that tells us the row in this metatile that we're in. And the metatile data is stored in binary form within these files here. But regardless, we can find the 8 by 8 tile in the metatile based on saying, okay, we're at this position, and the metatile is whatever the number is. We look up the metatile that we are interested in by indexing into this, where is that? We have a label for the metatiles, right? So we're going to index into the metatiles based on the fact that they're all affixed 4 by 4 tiles. And so what we'll do is we'll index into that, and then we can figure out from the row that we're looking for which row in the metatile we're interested in. And once we've crossed the 4th row, yeah, I think I was saying 8 before, but we actually only have 4 rows. Then we want to increase the value that we're using as our lookup start location into the map by 8, right? Because we just want to increment it into the next row of metatiles. And that's much easier to do for a variety of reasons. One, we don't have to do those shifts to handle the multiplications and the divides. And then also, we can still use that trick that we were using before with the bitwise AND to perform the essentially the modulo operator that we were using, because we're again indexing by a power of 2, which means that we're good to go to use that in order to ensure we're always counting up by 4. Now that said, we may actually probably don't want to do it that way, only because we do want to check to see if we've hit that number 4 and then increase this by 8 once we, yeah, I think that's probably, we don't need to do it there. So anyway, here's what I'm going to do. I'm going to, we haven't done a commit in a while, so let's commit the changes that we do have. because we know they're working. I mean, obviously they're not ideal, but they're working. So let's see, what have we changed? We changed the profiling script. Did I not install? I thought I installed Beyond Compare in here, but I'll have to do that later. So we changed this script to increase the number of counters that we're using. And somebody had asked me at one point to upload this to make it available for something they were doing. I will update the version on GitHub that I had posted to include these latest changes. So yeah, for that one, that's separate of what we're doing here, but so that one added new counters for game loop and IRQ. I believe that's right. Yep. So commit that change. And then here, I mean, obviously there are a ton of changes that we made. You know, but again, the reason I'm doing this is because I want to have this as a state that we can go back to if we, you know, really mess this up. Just like we did with the, the other code that we were writing, where we were trying to use data that we generated to load the sprites into the hardware instead of having it hard-coded from the asset tool. In that case, we had generated a stash of those changes, but I feel pretty good that we're not going to make significant changes to the way we want to do that, or I can't think of any right now that we would want to, you know, that I can say for sure we're going to do. So it's good as it is. So added tile loading, also changed to MMC3, changed map, changed mirroring to vertical. What else? Oh, added status bar, although it's empty. Stage selected, commit. All right, so we've got that in there now. So now we can break it and have little fear that we're gonna lose those changes forever. All right, so I'm just gonna change this stuff because it's not really necessary the way we were doing it, like I was saying before. So it was cool to try out. I mean, it was definitely a useful thing to learn. I'm sure we'll use that at some point. All right, so camera Y. Let me think about this. So what we want to do, I think I want to change camera Y. Oh, I remember why I was saying 8 before. I was saying 8 before because when we hit 8, we've displayed the 8 lines of the tile that was previously loaded. So we need that. We need to count that. And then we also need to count how many rows we've gone through in the metatile. And then from there, once we've kind of, it's almost like a 3 counter system. Once we've hit the 4th row of, once we've passed the 4th row of the metatile, then we're going to increase the metatile offset in the map to go to the next row of metatiles. So let's see. So we do have a camera Y. That's going to be our literally our Y pixel count, we are going to have, I think we could probably use these tile Y and mtile Y, because I believe they only get used in this load level call. Let's see. You know, you don't want to have too many. Yeah. You don't want to have too many unnecessary variables just sitting around here. So we have those. So camera Y. So let me change this. So the camera Y no longer needs to be a 2-byte value. Let's see, so that's good. This can go back to being 0, because, alright, so that's fine. So now we're going to load it and it, oh, do we never increment it? Oh, because we're doing, right, we're doing the 2-bit. So should just do increment camera Y, and then we're going to load it, and then we're going to compare it to 8. Branch if not equal, increment metatile row. That's going to skip the row load. What we need to do, we also need to say that when we come out of load level, tile Y is going to be done loading tiles. So load A, what's 56 in hex? 38. Store A into tile Y. So that's going to be our offset into the level. That is always going to be the same because we're always loading exactly one screen to start off with. And then mtile Y will be used for the internal increment, similarly to what it was used for during the low level routine here. So excuse me. So increment camera Y, load it into A, compare it to 8, branch if not equal. Oh, so this is branch if equal, and then otherwise jump to skip row load. So this is going to be increment metatile row. So increment mtile Y. Load A 0. Store A into camera Y. Increment mtile Y. Load A in mtile Y. Compare it to 4. Branch if not equal. We'll do the same thing just to avoid any sort of out of range problem. So branch if equal to increment metatile. I call that metatile. Call that metatile sub row. And this is metatile row. And then otherwise jump to skip row load, and then increment metatile row. We want to load A 0 and store that into mtile Y. And then we want to increment tile Y. No, we don't want to increment. We want to add 8 to it. So clear carry at Load A8, add carry, tile Y, store A, tile Y. And actually, this one is correct. We do, if we increment the camera's Y position and we're not doing any, we're not getting to a threshold where we have to load a row, we're going to skip the row load. Here, we've already determined that we've hit a threshold, so we now need to draw a new row. So we'll call this load new row. And this one is the same thing, except we're just going to do load new row. Now this is where we were doing all the crazy math that we were doing before for the 16-bit divide and multiply, and we're going to get rid of that. Skip sprite add. Yeah, all of this can go away. And now we're back to here. So here's our load new row. Actually, what was the memory address we were running? I want to just try this. Yeah, I just want to try this as is to see if we're hitting it when I expect us to be hitting it. And then we'll actually do the work of loading the new row into the name table. Okay, so that built. Go to the debugger. And then we were 7FC. Address, right, okay, and, okay, so that is a broken, or my breakpoint is busted. It's one of the two. Oh, I typed 7.4C, not 7FC. That makes me feel a little bit better. Okay, so that looks pretty good because you can see it increments roughly one row of tiles and then continues on. So that seems like that's pretty much what I expected it to do. That's good. So now we can actually load the row. So we know the offset into the metatile array, which is the map, right? How do we know which map we're looking at? I don't know. That's a good question. We don't have that loaded anywhere. I believe what we were doing previously, and I believe we were just assuming that it was going to be level 1 just to get that working. And we're using, I know we were using sprite mem because it wasn't necessary here to be used. So we were loading with, good grief, what was it called? Tables or map table or something like that. Maps. I don't know why I'm guessing when I can just look at the code. We were loading maps high, right? So, all right, load x0, load a, maps high x, store a into sprite mem, load a maps low x, store a into sprite mem. Plus 1, right? Plus 1. So that gives us, we'll just confirm that. That gives us our lookup into the map. So what we should see is that the location that memory is pointing to is now the base pointer of the map. So we'll open the hex editor too. And so let's see. So sprite mem is 1, 2, 3, 4, 5. So it's bytes 4 and 5 and memory here. 1, 2, 3, 4, 5. So it's 0, 2. That doesn't seem right. Did I do the store a maps high x. Let's take a look at what this said. It was 3 and 4. 3 and 4. Store a. It's weird. Why is that not what I'm seeing? So load a x, which is E6, so it should be E6 F9, and storing that in 3 and 4, which that's right, but those are not, those aren't the values that I see in here. Is this just out of date for some reason? It's weird that it would be. Okay, it was out of date. Well, that's good that I didn't go crazy looking for it and then find out that I was totally wasting my time. So E6 F9, E6 F9, E6 F9, E6 F9. So 2A, that's the beginning of the map content. We know that. That's the number of rows, so that's good. So what we want to do is I want to increment sprite mem plus 1 because that's whoa, what? Why did Visual Studio? That was weird. I want to increment that because we don't want to actually look at that byte right now. We want to look at the byte after it so that we're starting with the actual map data and not the length of the map. So why is not updating? So we're going to make it update. Okay, so E6FC. FC. Yep. Okay, cool. So that's where we wanted it to be. So now we know we're indexed properly to the beginning. Then what we need to do is we want to say, okay, let's take the offset into the map to determine the tile set, the metatile. So we want to say load a sprite mem +1, clear carry, add carry, and that's tile Y. And that's going to increment us past or into the new position in the map. So I apologize that I'm going a little slow on this one and kind of verifying each step, but you know, this is just one of those things where I feel like I'm more comfortable, especially after what we were doing before, you know, just kind of going through it pretty methodically just to make sure that we're always getting the right information at every step, rather than writing a bunch of code and then finding out we were wrong and then trying to figure out where we went wrong. So let's see, E701. So far that sounds good. We're headed in the right direction at least. E701. So what did it add? Interesting. Did it add to it? So let's see. So it did add the 38, which is what I wanted it to do. Dummy. Store a sprite mem +1. Helps if you store it in memory if you're going to use it, or reference it in memory. Okay. Hex editor. It's weird. I don't know why it doesn't. Alt C. E7 3B. Let's see what that is. E7 3B. E7 3 and B is here. E7 3. Okay, it's our number 8. That's good. That's the metatile we want. And now, from there, what we need to do is we need to say, okay, load a, well, so load Y with 0, load A with sprite mem Y. We're doing indirect addressing of sprite mem, so we're saying, okay, go to wherever sprite mem is looking at, and grab the value indexed off that address by Y. And I suppose we probably could have. The only reason that I feel like this might be a better, well, no matter which way we go, we're going to have the problem where if the map is larger than 255 bytes, 255 metatiles, then we would have to increase how we're handling we'd have to go back to making the camera Y a well, actually no, that's not true. The only part that would have to become a double at that point would be tile Y, or I shouldn't say a double, a 16-bit integer would have to be tile Y, because eventually we would exceed the value that this could offset into the map. But we're talking about 255 times 4, so 1,020 tiles. 1,020 tiles times 8, so that's 8,160 pixels, which divide by 240, so 34 screens high. I mean, I don't think, not that we couldn't. I mean, I don't know. Maybe we will, but I don't think we're going to exceed that, at least to start off with. We'll see. Anyway, so we've added that. We've now got the metatile loaded into A. So if we reload this and check A at the breakpoint, what we will see is that we should have in A the value 8 the first time through anyway. Don't. Why don't we? Y is 0, 3, F, E, 7. Oh, is it in backwards order? Possible. It'll be a quick fix if that's all it is. E2, so that's not right either. Load X0, load A. Where's our store? Our store is here. So we're doing load X0, 3, 4, E706. I thought this was right, but something else is going on. Let's see. This is kind of dumb that we're let's do this. Let's do this. Let's clear carry, add carries 1. Instead of doing the increment into the memory directly, I'm clearing the carry and adding 1 to A, which has the map's low byte in it, and then I'm storing it in memory, and then I don't need to do this because we have it. Excuse me, we have it already. And then I'm adding, well, actually, then we don't even need to do that either, because we're adding 1 and then we're adding tile Y, and then we need to store it in order to use it for this offset. So if we step over this, we say we are going to load that and store the value E7, and then we're going to add 1. We're clear. We're going to add 38, which is fine. We're going to store it. So now we should be seeing what? Hex editor. So E73C. 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 That is the right value. So Step over that. We're going to store it. And we're going to load y with 0, which it has. Yeah, so it's backwards. It's backwards. So let's write mem plus 1. And that's just me not being as familiar as I probably should be with the byte ordering stuff here on the NES. There we go. So now, like we wanted to, A now has the value of 8, which means we can use it to look into the metatile row that we want to extract, right? So what we do is we say, okay, have that in A. Let me think about this. So that gives us the offset into, oops, I thought I closed that. That gives us the offset into the metatile lookup. So what we want to do is we want to say now, whatever that value is, we want to multiply it by 16 tiles, right? Or no. You know, I honestly don't remember how we're loading those metatiles because it feels like it's been a million years. So, right. Okay, so there is a lookup for that, which has each of these. Metatiles bin. Does that have the offsets? Let me look. Honestly, don't remember. Just because it's been a while since I looked at that. I think it's just offset counts, but metatiles.bin, we write into it right size of char, empty metatiles. So that's writing 16 bytes. For metatile 0. And then based on this, we're writing a metatile. We're writing the background, the actual background tile lookup. So, for example, transfer A to X. Store A 2007. So it is just going to guess it's just the, well, we can even look at it. Well, it's just the index into what tile value it has. Well, yeah. So it's just the offset into, not the name table, into the pattern table for what tile we want. So it should just be, should be that now that we have that, we can just offset it by the number of tiles that we need to skip to get there. So what did I say? It's 4, so 16. So we want to shift 2, 4, 2, 4, 8, 16. So shift 4 times. Rotate left. So just 2, 3, 4. So that should give us now the lookup that we need. And then we want to transfer A to X and load A with metatiles X. And so let's see if, well, let's change this value of 8. Let's change it to be what? What do we want to change it to? Let's change it to 1 and see if it gives us a value that makes sense. Change it to 2. I'm going to change all of these back to 1 because we know now that that lookup at least is working correctly. I want to have it look up 2 so that we can see that we're actually getting something meaningful there. So move the breakpoint trigger to be here. Oops. All right. That's the thing. If you don't touch code for a while, you forget how it works. Here's the debugger. Okay. So A has the value 2, which if we look at the pattern table, has this. Okay, no, oh right, that's the metatile. So now we're gonna shift this to get the lookup into the actual metatile, and then we should see an actual, so 69, and these are hex values. Oh, they're all hex values, I forgot. 69, and that, yeah, that's right. So that's the first tile of that metatile. So that's cool. Okay, so that's the right tile, and now we just need to, that gets us into the metatile itself, and then we need to we actually need to increment X based on mtile Y, which is the incremental Y value, right? So load A load a mtile y, and that's just going to be a ×4 rotate left. So that's twice, and then clear carry. I really want to add, let's do this, store x into temp, add carry temp, transfer a to x, store a temp, we'll just do it this way, store a into temp, because then we need to load a with that, rotate, yeah, we're multiplying by 4, because each row within the metatile is going to be 4 regular tiles, and then we want to add that value to, we want to add the value of the offset into the metatiles with the row offset, and then we have our metatile value, or metatile starting position. Wow, tedious. And then we want to load the entire row doing this. So let's just start with loading the first 4 tiles here of the left-hand side. Make sure that that all goes according to plan. So what I want to do is I want to, oh Lord. Now I need to know what address on the screen I'm writing this to, and store that into 2006, and then so what I'm kind of just realizing here is our screen is made up of, this is mirrored this way, right? And so this is our main screen here, and this is our status bar here. And what we're doing is we're saying, okay, the scroll is going to get to a point, it doesn't even have to be at the top, but let's say the scroll is going to get to a point where it's got to load a row like this. So what we have to do is we have to store the address of this row beginning point into 2006 in which is telling the PPU, hey, this is the memory we want to manipulate, and then we do our writes to 2007 for the whole row of, you know, we just do the 32 tiles. And that, so what I was saying is we're going to need to, what I want to do is I want to handle just these 4 tiles in the metatile right now, going like that. Let's take a look at this memory, because the thing that's making me, whatever is the appropriate word you want to use, the thing that's making me kind of think about where we are and what we're doing here is so let's see. So this memory is, well, actually, it's not so bad. It's not so bad because we can, because this is mirrored, just keep writing, I think. Let me think about that, because we don't actually care. Yeah, that actually might be okay. We don't care about what's in here. We actually just want to, well, no, what maybe we stop doing... So what we were doing is we were saying... turn off this breakpoint. What we were doing was... You see how we're doing that smooth scan across the entire screen? What we're doing that because originally we were updating this. I was thinking we would update this as we went, but as it turns out, I think we only need to update this one screen. We don't have to do that jump because essentially these are the same. So we just start from this address 23A0 and work our way down to 2000 and then, you know, go back to that. Is there any benefit to... I mean, it's essentially the same. It's mirrored, so there's really no... It's not like we're using 4-screen memory where it would be potentially beneficial to make this work that way, where, yeah. Alright, so we can kill the swap that we're doing, because essentially it doesn't really matter. So let's see. Process scrolling. Load A, scroll Y. Set, clear, subtract, store A, compare of 0, branch not equal to done scrolling. Otherwise, load EE. That's okay. Store A, scroll Y. Load A, swap. So we don't need to do that anymore. I don't think. I'm going to comment it out. Because, like I said, now that it's mirrored, it doesn't really matter. We're not gaining anything. If we were mirroring the other way, then we could get a little bit of a smoother scroll because we would actually update without seeing anything on the bottom. That's the other good thing about having the status bar on the bottom, though, is that you don't have to worry about seeing that on the bottom because it's going to hide that update. So we should, yeah. So now you can see it's only just looping that way. Scan line 200. Yeah. Okay. So that's that. So that makes it a little bit easier. And I guess we need to have something called screen mem because we need to persist. Are we using these anymore? We were using, I think we were using that only for the code that was, yeah. So we can replace that with screen mem. So we were using that for the complex math we were doing for the camera Y position with the 16-bit stuff. Let's go back to... Okay. So we're here. We need to, let's see. The screen memory needs to be initialized to the appropriate position in memory that we want to write to next. So the next location we would want to write to after we get to the top of the screen would be this location, 23A0. So let's see. After we've initialized that, load A, 23, store A, screen mem, load A, 30, store A, screen mem, +1. And then bear in mind, these addresses are not memory addresses that the CPU can access. These are memory addresses that the PPU can access. So it's a whole different thing. Now, because this is 16-bit, we need to, this should be 2380. Because it's 16-bit, we're going to have to be careful about how we're doing our subtractions, but that's okay. Let's just one step at a time. So that's that. So now we have, so all I wanted to do to start off with was just really kind of cheat and say, okay, load a screen mem store a 2006 load a screen mem +1 store a 2006. I think we need to also do a load of 2002 if I remember right to kind of clear everything out. Yeah, okay, so we want to load that. We want to store that in 2007. All right, increment X, and then just humor me here. I'm just gonna keep doing. I'm gonna do that 4 times. So we load that one row of the metatile, because we're not even tackling the X part yet. Mr. Samoflange, Nscope is something that CA65 or the CC65 suite uses. So you create a scope like this, or within for example, a subroutine, you can create a scope, and that just means that any of the labels, for example, that occur in here are isolated to that scope, so that you don't have to worry about reusing labels that throughout your code that would obviously not work, because the assembler will flag that as a duplicate. In this case, because it's confined to the scope, you don't have to worry about it. It's useful for, especially if you're generating stuff or writing code that reuses a lot of stuff. So like for this, we have the scope for drawing the sprites. I just wanted to make sure that there was no conflict of any of the labels or anything that was going on in this code, since it's auto-generated versus this stuff that I'm writing by hand. And then you also use it to do things like I'm using it to define essentially constants, or it's more of like an enumeration here, where I'm saying that when I go to use one of these, I'm saying within the scope game state, I want to find load title screen or whatever else. Same thing for the tile load. So it's a useful thing. All right, so let me see. So I'm loading these 4, and then what I need to do after that is I need to decrement the address by 32, right? Yeah. So load a screen mem +1 set carry subtract 32 store a into screen mem +1 hexadecimal digit. Oh, I don't know why I did that. Okay. So that will work in and of itself. What we probably want to do here let me think about that. What is that going to do? If we do a subtract, we're going to get a flag set. Where is that? Where's my favorite little utility here? Yeah, I used NESasm, and it was good overall. I mean, it was pretty straightforward, but it was not. It was not as fully featured as CA65, and ended up just liking it better. So let me see. So if we set the carry and we load A with, let's say, 0, and then we subtract our 20. I forget what it's going to actually end up with. Set, so carry the negative. So the negative flag is set, which is correct. And if we have 0 and we subtract 32, what we really want to end up with at that point is what? So we're at 238. 23. Wait, do I still have the wrong? That is the bottom left. It's 23A0. All right, so where is, I actually closed calculator for a change instead of leaving a million of them open. So let's see, so 23A0 minus 32, okay, that's fine. Let's say we're at 2300 minus 32, we're going to get 22E0. So we want to change that to, all right, that's what I was looking for. So I almost wrote LOL. That is not an opcode, but it probably should be. Logical operator left. I don't know. I'm just getting tired. So this is our code here. We're doing this. And then I want to subtract 20. And then what I want to do is I want to say branch if positive, right? That's what that is. Branch plus. Okay, so branch if positive. Let's do the opposite condition. Branch of negative to handle process screen memory. Otherwise, jump to skip row load. So process screen memory, we're saying, so it should go to E0 basically. So load A, E0, store A, screen mem plus 1, and then load A, screen mem, or actually that we can just decrement that, right? If we're just doing, yeah, we just decrement that. So decrement screen mem. And that's easy enough. That does that in memory, and then we're done. So assuming I did not botch this too badly, we should see at least the left-hand side start getting loaded with some data. And what we can do to make this a little bit more interesting is right now the left-hand side is all these one. Let's make it alternate. At least this way it's a pattern where we'll see visually if we have it working right or not. It should be pretty obvious. Okay. Alright, so that's that. I mean, I have no idea if this is going to work right, but we'll see. Okay, so that's not working right, but why? What am I? Let's take a look at the name table and see if we can see anything obviously going haywire. I mean, I know there are only so many tiles. Wow. Okay. I guess the first part is, are we just messing up the way? Yeah, so okay, so that's the first part is just occurred to me that we are loading it in the reverse order again. Okay, so let's see now how that works. Well, I mean, it's loading stuff, but obviously not right. Let's take a look at the... Oh, you know what? There's another... there's another problem here. Once this... So we get down to this, and then we're going to minus 32 from that. So what we have to do... Right, so, yeah, so what we have to do is, after the decrement, we do actually have to look at this and say, compare it to 1F. And if branch not equal to skip, reload, and then if it is equal, we're going to load A, what is that? It's 28A0. Two 3A0. 23 store A screen mem load A0 store A screen mem +1. Okay, so basically what this is if we get to the point where we hit 1F on this part, then we know we've hit the top of the screen, and what we need to do is reset what screen mem is for the next time around, because we've gotten to the top. All right, so curious to know why it's flickering so badly. could just be because of the way we're interrupting it to load the data. You know, and it was working so well up into there. Let's see what's going on, shall we? Breakpoint. Alright, so we're at a breakpoint. Our breakpoint is we're gonna load 2002 to get ourselves ready to start setting up the memory. So step over. So we're gonna load A0. We're gonna store it into 2006. We're gonna load 23. Store it into 2006. And then we're going to load the metatile, which gives us 6D, which if we look at the pattern table, 6D is what? 6D is this. Okay. I mean, that's a reasonable value. So we load that into A, and we store that into 2007, and we should see an update in the name table that will reflect that. And we don't. Let's just confirm here. So we loaded, what did we load into 2006? We loaded A0 and then 2, 3. I'm wondering if that's just not... Well... Oh wait, it's already got the value 60 in it. Okay. Or not already, but it does have the value. Huh, okay. Oh. Wait a minute. Why... Did I mess up the math here? Load. Subtract with carry. Oh, yeah, it's not. It's branch minus, not branch NE for branch negative. Oops. Let's look at the name table here. So the funny thing is that already has 6D in it, but the important thing is that we're not going to do that branch for minus incorrectly now. So now we're okay. Let's see what tile we're getting here. Zero. Store into 2007, 0. So what address did it load into 2006? It loaded 28, no, 11, load A, E0, 20, E0, store A, E0, 22, that's not right, because if it was, wait, that's, oh, I'm looking at, okay, 28 E0, that's right. I was loading 22 into A and storing the value 71 to 2. No, load A. X. Saying the value is... Oh, it is 72, and then... Let's see. Doesn't seem to actually be updating that. It is partially updating. It is obviously doing some sort of updates, but not correctly. All right, let's think about why that would be. Let's go back to load level. We know that's working. And so when it's going, it's high byte, low byte, right? Did I mess up the order and it was fine? Because let's see, screen memory is high byte, low byte. Yeah, so okay. So we're saying high byte, low byte. Not that that's going to fix it, but we at least want to have the right data going into the right places first. And it's also really messing with the drawing. It's weird. I wonder if it's because of something to do with the way. I don't know. Anyway, I'd be satisfied if we got it to load the tile data correctly, even if the scrolling was still getting screwed up somehow. So this is okay in theory. Let me just see something here. Pattern name table. So there are 960. Okay, so that's the first thing. It's 23C0 should be. I think I'm messing with the wrong data. So 23C0 is going to be what we want to load into this. Oops. And then, actually thinking about this, 23C0 here. Oops. Hitting paste. And actually, now that I even think about that, 23C0 is the corner there, so it's not even that. It's what would that be? So that's 30. It's 30 rows of 32 tiles. So 3A. So actually, so I was right. 23A0, right? 3. Okay. So where is this? 2007 is what I want to look at here. This is the data, and 2006 is the address. So you write the high byte first, 2108, and then you write the low byte, and then you write your 2007s. Oh, I wonder if it's because I'm trying to do this while we're in, after we're done with the scrolling. And it's messing up because of that. Downloading tiles. Yeah, that's fine. So let's see. Because we let me see. Did we do the change? Actually, we didn't do that. We're in the game loop here, right? So that might be the issue. Right, this isn't the v blank. This is, so this isn't the v blank. This is the actual game code. And the problem is we don't know if it's safe to do this here, because it was saying you can read and write data through VRAM, through this port, should not be accessed outside of the vertical or force blanking because it will cause graphical glitches, and if writing right to unpredictable addresses in VRAM. So that's exactly what we're kind of seeing, is this weird behavior of it just randomly writing to places that don't seem to make a whole lot of sense. So what we should do is we should do that here. So let's see. So we set the scroll, we do all of this stuff. We'll do this here. Let's see if that makes any discernible difference without even looking at anything else. It's different for sure. Oh, it does sort of seem to be alternating. It's not. It's still getting some things confused, it looks like. Let's do this. Let's do it after or before. We'll do it after the sprites, but before we do anything with the scrolling. And I just want to change instead of loading A, we're just going to do bit on 2002. It seems like that's considered the right way to do it. I forgot. Okay, that's better. So let's look at our name table. So we are seeing updates, and it's definitely a little bit smoother than it was previously. I'm not sure why we're getting this with the flashing. I mean, it seems like it's close because we are getting the alternating. It's not every metatile that's getting loaded like that. It seems to be every other similar to what we wanted, but it's obviously still not right. All right, let's debug this. Let's power cycle, hit the breakpoint. so we're at the point that we're going to load our first tile. And the value is 6D, and we stored it, and I mean there's no change there because that's what the value actually is already. Let's go to the next row. So we're doing 2, 8. We're doing 2, 2. Wait, why is it 2, 2? It was 2, 3, A0 before. It should be, is there a typo? Two, 3, A0. Okay. Load A. That is wrong. And that's wrong too. Why are they both wrong? So let's see, 2, 3, and A0. That's so far so good. Let's go to the hex editor. Where are those? 2, 3, A0. Okay, it's right here. Very easy to spot. So we're going to go through this process. We're going to load that tile. We're going to store it in 2007. We're going to increase. We're going to go to the next one, store it. Next one, store it. Next one, store it. We're going to load A with the value A0. We're going to set the clear. We're going to subtract 32. We're going to store it back. So A0 became 80. Why doesn't this update? Okay. And then we're going to branch if minus, which it shouldn't be. Oh, it's set. Do I have to clear that? It shouldn't need to be cleared. Oh, damn it. Right, because of the range value of values. Crap. Well, that was just stupid. Is there a better way to know that? Well, it becomes E0 anyway. I guess. So what I the problem is that even if it doesn't go from 0 to E0, the issue is that E0 is a negative value with the 8-bit sign. So branch of minus is a dumb way to check that, and it was just silly on my part. So compare it to the value E0 and branch not equal branch if equal to process screen memory otherwise. So basically all I'm doing is I'm saying that, you know, if you subtract 20 from 0, you're going to get E0 anyway. And the only reason we're going to get E0 is because of that subtraction, since we're starting off at A0. All right. Okay, so We'll check this a couple of times before we just kind of let it ride. So 2380, we're going to step over. It's going to do its thing and populate the tiles that are there with the value that was already there. We're going to subtract. We're going to store it. So now this will be 2380, and we're going to compare it to E0, and we're going to jump, which is good. And then we're going to what are we doing there? Oh, right, now we're doing the scrolling. And now we're going to come back to the next row. We're going to say, okay, load 2380. And then we're going to get the tiles that we want for that. And we're going to update those. Name table. And we're going to store those. So that was 72. 71 and now 72. I guess we already have those in there. So hopefully on the next line, yeah, so we are, okay, so it is, it is updating it now. It looks like it's updating it correctly in terms of, you know, the memory being updated. Okay, that's cool. So that's not actually terrible in the sense that it's at least doing partially what I expected it to, in that it is updating, but it looks like it's updating it at a different rate than the scroll is occurring. Oh, right, because the scroll, can anybody guess why it's happening at a different rate? If you guessed that it's because we're subtracting 2 from the scroll, you would be correct. So I'm going to readjust this and make this subtract by 1 so that the rate matches. There we go. That's okay. So that is actually doing what we want it to now in terms of loading the alternating tile patterns. Although they are skewed, they are loading, and it is alternating. And now we're going into garbage because the level is not that long. And now we've looped over. So the question now becomes, can we figure out why this is occurring? My guess is that if we were to throw this into our good friend FCEUX, what we would see if we brought up the profiling is that we are potentially overstaying our welcome in the NMI. It's not that bad. Is it just because of... Yeah, that's not that bad. Why is the IRQ alternating? It's almost like the IRQ is happening every other frame. Which is weird. I mean, the interrupt is using 34 cycles. The NMI does not appear to be using much in the way of cycles either. Simulation speed. How do you pause? It's the pause key. (824 cycles). but then there's no IRQ listed. So it's like every time the IRQ, every time NMI takes a little bit longer, the IRQ isn't firing. Okay. I can't tell if that's because this is taking too long or we're messing something up for when we go to this. So store a easier. Right. So we're basically, let's see. Let me do this. Is it because of where? Is it because we're doing this here and now in the beginning of the NMI? I mean, it shouldn't. I mean, we're really not doing that much that I would think that it would cause. Let's make this happen later. I don't know if that's too late. It's still... still flickering like that. It just seems like it's something weird with like every other frame. It's, or maybe it's every, is it maybe every 8th frame where the scrolling. Yeah, that would make sense. So it's every time we hit a point where we have to load another row that's causing this to break. Let's see if I turn off the code that actually manipulates the PPU, let's see if that stops the breakage. Basically, I want to see if it's because we're manipulating the PPU or if it's because of the code. So if it's the code, we should still see this even though the tiles won't load. If it's the manipulating the PPU, then the status bar should continue to work, should start working properly now, but obviously we won't see any updates. Okay, so it's manipulating the PPU that seems to be the issue, because now our status bar is looking pretty much as expected. We could even, where is that C0? I wonder if it makes sense to move that later. Is that oh, that pushes it down. It doesn't. Okay. So that's the problem. The problem is that we are manipulating the PPU in a way that then the NMI is being affected by. Or not the NMI, the interrupt. So when we go... That's weird, though. Like, what would cause that? Load A2, store A. Okay, this is just timer stuff. Very strange. I really want to know why that's interrupting the interrupt, or breaking the interrupt. Let's see. Let's see if there's any words of wisdom here about this. Is there something where the changing the PPU can turn off an interrupt temporarily. Let's see, this is the name table. Take a look at the mapper. See if there's anything in here. I mean, should we... I was setting the interrupt counter stuff here at the beginning because it just seemed to make sense to do it. But maybe we do it at the end. I didn't really want to do it at the end because it seemed like it didn't make sense to do it that way. Yeah, that had no effect. So just something about the manipulating of the CPU, sorry, the PPU at the time that we are loading more tiles that is causing this problem. Scanline counter cannot be stopped. Writing to E0 will only prevent the MMC3 from generating IRQs. The counter will continue to run. Writing to E01 will simply allow it to generate IRQs. The counter remains unaffected. Writing to C01 will cause the counter to be cleared and set the reload flag to true. It will be reloaded on the next rising edge. Writing C1000 does not immediately affect the value with the counter. Where N is the value written to C1000. Counter will not work properly unless different pattern tables for background and sprite data are used, which they are. Counter is clocked on the rising edge no matter what caused it. Oh, that's what it is. The counter is clocked on each rising edge of the PPU no matter what caused it, so it is possible to intentionally or not clock the counter by writing to 2006 regardless of whether the PPU is... That might be it. I wonder if that's what's causing this. That those writes to 2006... The question then becomes why would that matter for the camera stuff but not also for the sprites? It doesn't matter because we're not doing anything for this. We're setting these guys up. We actually don't technically... Do we need to even do that? We don't even need to do that because we're not really even doing anything with that. So, I mean, I don't know that that's gonna fix it. It wasn't necessary. So, interesting. So our updates to this, I guess, are causing the IRQ to improperly lock the camera by writing 2006 regardless of whether PPU is or is not rendering. But it still doesn't make a whole lot of sense to me. I mean, if that were the case, then what? We would just... or just force it to... I mean, that... yeah, I didn't think that would matter. It's just going to change where the... scan line is that we do that. So then the question becomes, does that mean we have to switch to sprite 0 to make this work? I mean, I can't see why we would need to. I know when we were looking at Guardian Legend, it was using sprite 0. Hey Memblers, yeah, I thought so. I was doing it here at the interrupt counter setup. Where is that? So, right, that acknowledges it. Yeah, I mean, I'm not sure how much you were watching, but I did notice that turning off the writes to the PPU at the point that we're loading the row, if I change this, then the status bar comes back the way that we want it to. So now that's... I mean, the status bar is working fine, but obviously it's not writing these tiles. So it's something specific about that code that it doesn't like, because as soon as I put that back, we get that flickering effect again. And in the interrupt handler, I am acknowledging it here, right? Because you just write E1000, you write to the E000 address in order to acknowledge it before you do anything. Wonder if it's because I'm turning it back on. I'm re-enabling the interrupt right after I acknowledge it and disable it. Should I maybe be waiting until I'm done to allow interrupts to happen again at the end? Seems like it might be better, just so that you don't have the IRQ trying to happen at the same time as the NMI. It's still doing the same thing. Don't need that. Well, we can try what you suggested. I'm open to anything. So let's see. Let's go back here. So he was suggesting that we turn off NMI during the interrupt. And okay. So do it after my counter starts. just want to make sure that there's not anything. Turning on my errors. Okay, so basically what I want to do is I want to load A with zero, 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 1, 0, 0, 0. So 0, 0, 0, 0, 1, 0, 0, 0. And then store it into 2002. 2000. Do our stuff here, and then turn it back on here. Right, I'm not doing anything any differently there. Okay. That is different. Different, not better. Well, you know what, I'll comment this out. Take a look at something here. I'm gonna go back to the mapper, and there's something. Fetch the name table. Blah, blah. A12 remain low during all name table and background pattern fetches, and high during all sprite pattern fetches, causing it to oscillate exactly 1 time per scan line, and 241. It may oscillate more if a program uses registers 2006 and 2007 to access PPU during fblank, but this is rare because very few games have MMC3 and char RAM. Yeah, but I guess that has nothing to do with char RAM in this particular case. This is specifically related to updating the background. While we're doing this, the scanline counter will also work when the background uses the right pattern table and the sprites use the left. This is less common. Well, I think I'm done for the night. I hate to leave it in this state, but the only thing I can think of to try is to see if we switched back over to sprite 0 detection, collision detection, if that would, or whatever you want to call it, sprite 0 hit, see if that would make it work more reliably. I assume that it's just because we're actually doing the update to the background, and maybe that's why a game like Guardian Legend would use the sprite 0 instead of using MMC3. I mean, I don't even know what mapper it actually uses, to be honest. Let's take a look and see if we load that up, and let's see what mapper that was using. Where is that? File info. So it's using Unrom. So it's hard to say if they went that way because of cost, or that there were no limitations that it had for them, or if, I don't know, that's weird. I don't know enough to know if this is going to be, if this is solvable. So I'll need to play around with this a little bit more, see if I can do some research on this, and hopefully figure out what the problem is, and we'll code it up on Thursday. Thanks for your help, Memblers. Appreciate it. And if anybody watching, although I can't say that I showed myself to be super knowledgeable in this particular stream, but if anybody has any questions, you can reach me on Twitter at Claravis, and I'm on Nintendo Age and in the Nintendo Age Discord. And of course, you can comment on the YouTube recordings of the session, and I will post them on Twitter and on Twitch as soon as it's uploaded. So have a great night, and see you Thursday.